warahmatullahi wabarakatuh. Let me introduce myself. My name is Wahyu Aulia. I'm student of Padang State University. I'm from the Department of Mining Engineering. My student number 18080038. I want to show you how to practice about close polygon use total station, and I want to introduce for you some tool. And here you can see first tool. I will use two tripod and yalon, and then I will use pole, and then here you can see I will use three measuring instrument, and here I will use meters, and which is I use helmet safety and safety vest, and then umbrella to protect your total station and your tools. And then I will use detail prism, and then polygon prism, and then total station. And the last one, I will use unting and compass to measure, to answer angle north. Okay, after that I will use measuring instrument. I will use three measuring instrument. It is for mark point. The point is STN, backside and foresight. The next steps is standing tools. I will standing tripod in first of tools, first of bowing. After that, put the total station on the tripod. And don't forget to lock. After tripod and total station standing in STN point, the next step is standing tripod and polygon prism in backside point. After that, put polygon prism on the tripod. And don't forget to lock. After that, standing pole and detail prism in the foresight point.
After that,
and lock prisma detail on the pole. And don't forget to centering circular level. After that, don't forget check total station was fixed or not with measuring instrument.
mana sih?
Measuring instrument is fixed with total station. Next step is centering the total station. I will centering the total station with using it, and then after finish it, Nivo bubble will centering like this. Yeah. And then the next step is centering the Nivo tube. You must rotating the total station about 19 degree, and you can start centering. After it has centering, you can see like this. Nivo tube it has centering. After total station has centered, now I will centering prism, and not two different steps. You must use it to centering. After it has centered, you can see like this. Bubble is the center of Nivo, and then I will center the top of bubble. You must rotating 90 degree and put the bubble in center of top, like this.
Semua kebenaran itu juga salah. Makanya
after polygon prism has fit with measuring instrument, you can see like this. Okay. After polygon prism and total station has centered, the next step is searching north point with compass. After north point has found, we must mark the point with yellow. And north point has found, lock the total station and mark north point. After that, turn on the total station, click power to turn on, and then you will found like this and set the total station. After that, click angular and set now the station with north point. Yeah. After that, rotate the total station same direction clock to find the azimuth point, azimuth angle, and then don't forget to note the angle. This is the angle azimuth. Okay, next step I will measuring height of this total station, prism polygon, and detail prism. Now I will ask helper of my friend for measuring the total station. Now I will measuring height of the polygon. After that, click a job. You can click menu toggle, menu keyboard, menu like this, and choose job, enter it job, and then create. Click MSR1, and you can create your name job. Wahyu, I click Wahyu for my name job. Enter, and then OK. After that, click SDN, and then noun, ST1, no, ST2 there I mean, and then click the coordinate of this total station. I can click 1000 and Y 1000 and Z for I click 10, and then CD or code you can click benchmark or BM and enter, and then hide the total station. The highest total station I has I have get 1.5 and then enter, click angle and backside 1 and then hike the backside point 1.4 and then code of backside, and you can click at AZ, you can click azimuth before 918.2423, enter, and like this. After that fix the total station shoot to make some like this. After that fix total station shoot to backside like this. And after it has fixed total station to backside, you must click MSR1, and then we'll found you display like this, and MSR1 record. After it has recorded, you must click MSR1 again, and you will find the coordinate like this, and it is this display 4, display 1, display 2, and display 3. After it has fixed, you can input your PT and HT. HT is height of foresight, and then code and enter. And after it fits, you can click MSR1 to get the data, and then you have gotten your data like this. And display 4, you will get coordinate X, Y, and Z. And display 1 HA, VA, and SD. Display 2 HA, VD, and HD, and like this. And the last, you record first. You click enter to record the data. I will move total session to point 3 and polygon prism to point 2, detail prism to point 1. Here I will ask my friend to help me. After you move your total station here, and first time you will centering like this, you can rotate, it is centering, and when it's centering, you can see like this. Yep, you can look, it is has centered. And then also centering in polygon prism, and same step like before, and rotate it is until centered, and when it has centered, you can see like this. Yep. After that, I will show the backside point. The first time I will click STN and click noun. For ST, I will input 3, and then for high I will input 1.5 and coordinate. Here I will shoot backside point. For backside point I will input 2. Yep, right, and then enter. And after that I will click MSR1. And after I click MSR1, you will see here coordinate 2 of this point. Display 1, display 2, display 3, and 4. After shooting backside point, rotating the total station to prism detail, has fixed, I will click enter, and here I ask to input the data for PT. I click PT1 and high 1.5, 1.4, and code for code backside and enter. After it has fixed, you can click MSR1 and you will get the coordinate here like this, and it is display 4, display 1, display 2, and display 3. After that, I will move gains once again. Total station 2.1, detail prism 2.2, polygon prism 2.3, and then same like before, I will ask my friend to do that. After total station has moved to third time, and the next step I will center the total station by rotate it. After total station has centered, you can see NIFO like this. Is the value of the centering and NIFO, top of NIFO, and I have fixed total session with measuring instrument. Step, I will shoot backside point. I will fix the total session with backside point first. After it has fixed, I will click STA, and now for ST I will input, it is the point of 1, and this the coordinate of point 1. Is it right?
Yes.
And then 1 point, for high the total session 1.45, enter. After that, I will shoot backside point by click STN, and here I will choose noun, and then for ST I will choose 1, it is 4.1, it is the coordinate of point 1, and then for the height of total session 1.45, and then I will enter. Here I will choose coordinate, and for backside point I will choose 3, and then for this the coordinate of backside point, and then for height of backside it has right, and then here I will fix, and after it has fixed I will click MSR1 after the enter, and then click MSR1 again for found the coordinate, and it is the coordinate of point of backside. I will enter for record. After shoot of point backside for 3 time, and then I will shoot prisma detail for 3 time. I will rotate the total station and fix the foresight point. Here I ask to input data. For PT, I will choose, it is PT of 2, and then for height of foresight point, and then enter, and MSR1 to found the coordinate of prisma detail. Yep, I has found the coordinate for display 1, display 4, display 1, display 2, and display 3. Okay, I have finished or collect the data in by total session. Then the next step is analysis of the data. Assalamualaikum warahmatullahi wabarakatuh. Okay, I want to analyze my data which is I get from our total station before our practice in rectorate. So this is the data. I have note the data in whiteboard for point 1, point 2, and point 3, and coordinate. So I want to analyze. Step 1, I want to correct the angle. So I want to I have input formula. The formula with sigma k b plus sigma b and equal n plus 2 and multiply 180 degrees. So it is the next of formula, and I input 3. Why did I have input 3? Because I have 3 points. So I have multiply with 180 degrees, and the result is 900 degrees. And next, I have not found sigma b, so I want to find a sigma b first, and I want to input a formula. A formula is I use angle, the biggest of angle in here. So the first angle is azimuth, and I input azimuth in here. So the next, I don't choose azimuth because HL is bigger than azimuth than HA. I mean, so I input HL in here and HL again. So the sum of all angle is 999 degrees, 56 minutes and no second. So next, I want to back to this formula again. Input this result to here, and 90 degrees minus this result. So the result is no degrees 4 minutes and no second. And this result, sigma of KB, sigma of KB per n, because n is total of the point, and total point we know before is 3, and no degree for minute and no second per 3, and the result is no degree 1 minute and 20 second. After I have found correct angle, so I want to input a correct in here in the x. So I will find correct x, and the formula of correct x is HD multiplication alpha and plus correct c. So I want to find per point. The point 1 is the x from 2 until 1, and HD is I look here. I look from here. The point of 2 until 1 is 9.37. Sin alpha is 201, 41 minutes and 41 seconds plus correction that I have before, and the result is mean 3.46 meters. So and second, the x from 3 until 2, then same formula that before, but a different HD. HD is I get from point 2 until 3. HD is 10.21 since alpha point 3 until 2 is 78 degree, 70 minutes and 28 seconds plus correction that I have before, and the result is 9.99 meters. And then the third point is the x from 1 until 3, and I use same formula like before, but different HD and different alpha. is HD. I have get from my point 1 until 3. The HD is 9.32 multiplied in alpha. The alpha I get from alpha point 1 until 3 is 15 degrees, 43 minutes, 26 second, and I plus from correct. I plus with correct. See there. There I mean the result is mean 6.50 meters, and sigma dx. The next formula is sigma dx. Sigma dx is total of this result, and I have total. This result is minus from point one from here and from the last result. So the total is 0.03 meters. Okay. So there I have before I have found result of dx. So I want to prove point per point with formula d per sigma d multiply sigma dx that I have found before. I want to prove point per point. Then for d for in this formula for d seems like before hd uh, from the result that have found in total station before. So for point 2 until 1 is 9.37 per result all of the point 28.9 multiply with correction that we have found before, and the result is no point no 1 meters. Next, same like before and same formula, but different point. Here, I will find point 2 until 3, and the result is no point no 1 meters. Next, point 3 until 1, same formula like before, and the result that I have found is no point no 1 meters. And all of the result, result 1, result 2, result 3, uh, uh, 1 plus 2 plus 3 that I mean, and the result all of the point is no point no 3 meters. That is previous like before is same. Next analysis is distance for point A, and now dy 1 dy 1 until 2, that not two different formula like before, but just little different, because before here I use sin for EA distance. I use cos multiply alpha. That now I want to start from point 1 until 2 is point 1 until 2. HD is we have if, from here input to here cos alpha. The alpha is here input to here, and plus with correction data that we have before. So the result is mean 8.70 meters. And next for before, same formula like here, but the data is point 1 and point 2 that I mean until 3, that we for HD or distance input here to here cos from azimuth 78 degree 70 minutes 28 second input from here to here, and plus with correction data that we have found before, and the result is 2.06 meters. And next, same formula like before too, but it is 0.3 until 1. 3 until 1 that we HD we get from here to here, and for cos alpha, the alpha we get from azimuth input to here, and plus with correction data that we have found before. So the result is 6.67 meters, and all of the result will collecting or total of the point is day 1 until 2 here, plus day 2 until 3, and day 3 until 1 that we have collecting, we get result 0.03 meters, same like before. Okay, now I want to find the y correction to prove with formula before. Now I want to find point per point, for point dy 1 until 2 correction. The formula is d per sigma d multiply sigma dy that we have found before. Then input d is get from here 9.37 per total of HD 28.9 multiply with correction dy that we have found before is 0.03. I get result 0.01 meters. And then the next dy 2 until 3 correction, same formula like before. Input the d, but d you get from here, from point 2 until 3. D is 10.21 per 28.9 multiply with correction data dy that we have found before, and the result is 0.01 meters. Now for d per for third time, the formula day 3 until 1 correction, d per sigma d multiply sigma dy. Input the data we get from here 9.32 per total of distance 28.9 multiply with correction data that we have found before, that we have get before. The result is 0.01 meters. Analyze and last total of our formula we get from here, calculating to total 0.1, 0.2, and 0.3. 0.1 is 0.01, same to 0.2 and 3. We total and plus 1 plus 2 plus 3 get result 0.03 meters, and the conclusion is correction dy that we have get here, same like before. Okay, now I will find correction for coordinate. So first, it is if total station in point STM2, and this result is I get from total station. So now I will find backside and foresight coordinate. First, I want to find backside in the point 1. X point 1 and Y point in 1. So the formula is for backside point 1 x2 plus HD horizontal distance 1, because in point 1 until 2 horizontal distance 1.2 sin multiply sin alpha 1.2 plus correction distance that we have found before. And then input x2 we get from here, input to here, and plus with horizontal distance 1 until 2, horizontal 1 until 2, yeah, input to here, multiply with sin alpha 1 until 2 is azimuth, so input to here, and plus with correction that we have found before, and the result is 999.202 meters. And next is y.1. Same formula like before, but here use y2 that we get from here. But the little difference is here, but in y point I use cos, multiply cos alpha. For HD is same, oriental distance, and cos alpha or azimuth is same, and plus with distance correction that we have found before, and the result is 991.465 meters. So next is backside point. If Sn in point 2, backside point is foresight point that I mean in point 3, x3 and y3. Same formula like x1, but delivering just in HD and input data HD and input data alpha, because it is a different point. So 2x2 is same that we get from our coordinate before, and plus with horizontal distance 2 until 3, yeah, 2 until 3. Input from our data to here, sin multiply sin alpha 2 until 3. 2 until 3 is yeah, 2 until 3 data HA input to here, plus with distance correction or correction distance, and the result is 990.171 meters. And next is y3. It's same like before, but different HD and alpha because different point. For HD, for y it's same, and plus HD horizontal distance. Same we get from here, horizontal distance 2 until 3, and then multiply with cos alpha. The alpha is same with before and before. It is input to here, and plus with correction distance, and result get 998.101 meters. So next I will get same formula, but I'm not analyze. I will not show analyze, but same formula. But if tools or total section in STM1 and STM2, but the difference just use same formula like this, but just the difference just use HD, the different point, the different just SDN alpha, and I have found the result. The result is for SDN1. The result is for X point 100.1 1000 that I mean point 169, same as Y point, the Y coordinate, So the have I calculate STN2 and STNY, the difference coordinate both of these point, both of different is 0.001 meter or 1 millimeter. Okay, that's all from me. Tutorial closed polygon use total station. I'm sorry for many mistakes. Assalamualaikum. The last, assalamualaikum warahmatullahi wabarakatuh.